A mechanical wave can be defined as a disturbance in matter that transfers energy through the matter. We will use this wave machine to see the origin of the wave that happens when the matter is disturbed. Our objective is to determine what happens when we increase the tension, also to demonstrate classic physical parameters seen in the wave motion, such as maximum acceleration, maximum velocity, period, frequency, and velocity of propagation. To make our wave machine, we use tape, gummy bears, and wooden sticks. We place the wooden sticks in the tape with 5 centimeters between each other. Then we place gummy bears in each tip of the wooden sticks. We end up building a system of 40 wooden sticks in the tape. The final length of the system was around 2.15 meters and the weight was 388 kilograms. Now that we have our wave machine, we can start with the theory. But first, let's start with the data we know. The data we have for sure are the length, the weight, and the different times applying different tensions. Also determine the linear density by dividing the weight between the length. Now we get the velocities. We obtain these velocities by dividing the distance between the time it gets an oscillation to complete. And now we can determine the tension by using the formula. By multiplying the linear density times the velocity squared, we get the tension that was applied in the rope. And now we apply different tensions. In the second one, the tension is bigger because the velocity was higher. To analyze the sinusoidal wave, we use the following formula. J is determined by x and t. Now, in the formula, we see a positive and a negative sign. But why do we see this? We use a positive sign when the rope goes from the right to the left, and the negative one when the rope goes from the left to the right.
Using the partial derivative of the initial position formula, we can obtain the velocity formula. And applying a second derivative, we can obtain the acceleration of the formula. Now we are going to analyze the maximum amplitude, the maximum velocity, and the maximum acceleration. As a result from the data obtained from the experiment as tension, velocity, period, and amplitude, the result of frequency was 0.28 Hz and final period of 3.75 seconds, also the angular velocity of 1.75 radians per second. Now that we have the A as an amplitude and the angular velocity, we can obtain AW as 12.12 meters per second obtained from the first derivative. Also, we can have from the second derivative AW squared equal to 0.214 meters per second squared. This is the maximum acceleration. As a conclusion, we can observe that if you increase the tension, the velocity will be increased too, or if you put less energy, the system and the propagation of the wave will be lower. Now, taking as a consideration the last part, we can see that there is a connection inside the equation of energy and mechanical movement.